Let's solve this problem. The question is to find out the current through this 5 ohm, and you have to apply a Thevenin theorem to find out this. Let us give it a name as A and B, and let us redraw this circuit once again. And let me keep it over here. So in Thevenin theorem, what you have to do, remove the load first, and we can extend this wire over here, name it a, this one is B. Now you need to find what is VTH, and that is nothing but it is VAB. As we can see that in this circuit there's a current source and a resistor, and we know that if there is a current source in a in a path, the only current which will flow in this wire is 5 ampere. No other current can flow through this wire. So this current can be termed as 5 ampere, which is flowing in this closed circuit. So the current is flowing in this loop is 5 ampere with a plus and minus sign across the resistor depending on the direction of the current. Similarly, with this voltage source, if the current is flowing in this anti-clockwise, since the voltage is 20 volt, net resistance is 5, so 4 ampere will flow in the anti-clockwise. So what we can do, we can write then that the current which is flowing here is 4 ampere, and the current which is flowing in this mesh is 5 ampere. So obviously we can note down the sign across the element 1 ohm and the 2 ohm resistor in this way. So we can write VAB is equal to 1 into 5 VAB in this way. So 1 into 5 minus 2 into 4, that is 5 minus 8 minus 3 volts. So we can conclude that VAB is equals to minus 3 volts, and that is nothing but is equal to VTH. So we get one answer. Next, what we'll do, we will take the same circuit once again and redraw it. So we redraw the same circuit once again, remove the source and replace the source with its internal resistance. So the voltage source we will remove and replace it with the internal resistance, that is 0. The current source we will remove and replace it internal resistance, which is infinite. So this terminal shall remain open circuit and this side terminal is short circuit. And the load we will remove, so that our objective is to calculate what is RAB. Now this circuit is very easy. You need to find what is RAB. What is the path remain is like this. Here there is a split, so these 2 and 3 are in parallel. So what we can write, RAB is equal to 1 plus 2 and 3 in parallel, so 2 into 3 by 2 plus 3. So you can say 5 plus 6 by 5. 11 by 5 ohms. So we get the value of RTH, which is 11 by 5 ohm. Now, as per Thevenin theorem, the load current IL is equal to VTH by RTH plus RL. VTH is minus 3, RTH is 11 by 5, and RL is the load resistance. This is RL, load resistance. You can observe that when we redraw this circuit, we remove the load resistance in all. So we write here load resistance is 5. Now solving this, we get minus 15 by 36. So we get finally minus 5 by 12 ampere as a load current. This IL is the current which is flowing from A to B. So that is minus 5 by 12 ampere. And that's the answer. Now what we will do, we will keep it as it is and we will solve this problem once more with the mesh analysis. The moment I am using a mesh analysis, I am using this problem as taking the 3 meshes together. 3 meshes separately we will take and determine the current I1, I2 and I3. Once again, we will determine the current I1, I2, I3. In the mesh analysis, whatever the answer we will get in I2, it should be same as from Thevenin theorem, whatever the value we get, minus 5 by 12. So here is a problem. We will solve it using mesh analysis. So using mesh analysis, we will solve the same problem. So we will take the 3 meshes as I1, I2, I3. 3 mesh current as I1, I2, I3. In mesh 1, we get the current. You can see that in mesh 1, there is a current source is there. So if in this wire only 5 ampere will flow, no other current can flow in this wire. However, here in this 1 ohm resistor, you have 5 ampere as well as I1 and I2 both will be flowing. That means in 1 ohm you have got 2 currents, I1 in the top to bottom, I2 from bottom to top. So the current I1 which is there in the mesh 1 must be 5 ampere because same current is flowing from this wire, and since current source is there, no other current can flow here. So we can write I1 is equal to 5. Simple first equation. Then we write for the mesh 2. Equation for mesh 2. Remember, this is a mesh 2. We choose the current direction all clockwise so that we can write the equation quickly. When we write for the mesh for equation mesh 2, we can write it together like 1 into I2 minus I1, then 5 into I2, then 2 into I2 minus I3 is equal to 0. Also, we can write in an easier way. If we write like this, all the terminal, we can write it easily as if like minus of I1 plus 1 plus 5 plus 2, 8 I2, and minus of 2 I3 is equal to 0. So this is my second equation. The equation for mesh 3, we have 2 into I3 minus I2 plus 3 into I3 plus 20 is equal to 0. So here we could have directly write the equation minus 2 I2 plus 5 I3 is equal to minus 20, equation 3. Now we will substitute the value of this I1 in this equation 2 and rewrite equation 2 here as equation 4. Eight I2 minus 2 I3 is equal to 5. Now we have got two equations, this and this. So what we do, we write equation 3 once more with multiplying this entire equation 3 with 4 so that the I2 coefficients will get cancelled out. So I'm rewriting the equation 3 minus 8 I2 by multiplying 4 over here. 4, 5, 20 I3 minus 80, equation 5. Simply add it. We get here 18 I3 is equals to minus 75 I3 is equals to minus 75 by 18 divided by 3. So we can write I3 is equals to minus 25 by 6 ampere. Substitute the value of I3, we will get I2 is equal to minus 2 I2 is equal to minus 20 minus 5 into I3. I3 is minus 25 by 6. So this is nothing but minus 20 plus 125 by 6, or I can write minus 120 plus 125 by 6 . Now this is equals to 5 by 6 minus 2 I2 is this, so I2 is equals to minus 5 by 12 ampere. So from these two we can get, so now we have got all the three currents, I1, I2 and I3. So if somebody asks here what is the current from this 5 ohm we can write the 5 ohm, the current from this 5 ohm is nothing but I2, that is minus 5 by 12, which is the same when we evaluated this minus 5 by 12 by Thevenin theorem. Again, if somebody asks that what is the current which is flowing from this 2 ohm resistor, you can write current through 2 ohm is equals to, in the 2 ohm we have a current I2 which is going down and I3 which is going up. So net current in 2 ohm is I2 minus I3. I2 minus I3 minus 5 plus 50 by 12. Sorry, that's not. 15 by 4 amperes. So what we get is the I2, the current which is flowing from the 2 ohm resistor is 15 by 4 ampere, and that's the answer. So 15 by 4 is the answer of this. What is the current flowing from 2 ampere, 2 ohm resistor? So we have done this with a mesh analysis. We get the current from 2 ohm, that is coming around 15 by 4. We also get what is the current from this 5 ohm, that is minus 15 by 12, which is same as minus 15 by 12 when we solve by using a Thevenin theorem. Now, why don't we use some trick over here? Let's say node analysis we will use in an easier way, right? We use a source transformation. So again we have a problem. We will try to use the source transformation here. So here we are going to use source transformation, and are we getting the same current through the 5 ohm resistor? So source transformation means that if there is a current source and a resistor in parallel, you can convert that into a voltage source and a resistor in series. Okay. So we can redraw or rewrite this as a voltage source in series with the resistor. The voltage is nothing but 5 into 1 and the resistor is as it is. Rest other resistors we will connect, and we can connect the circuit as it is. Now the question remains same, what is the current through 5 ohm? You can simply solve it by using node analysis, and assuming that all the currents is going out, you can write the equation at this node A. So we can write VA by minus 5 by 6, VA by 2, VA minus 20 by 3 is equal to 0. How we get it? This one is the current which is going downward is VA minus 5 divided by 6. The current which is going through 2 ohm is VA by 2. The current which is going from this 20 volts is VA minus 20 by 3. We are assuming that this is a reference one. So solving it, So this is VA. This cancel out. So VA comes out to be 15/2 volts. If VA is this, if you substitute here the value of VA, you will get the current in this direction. You make a negative of it, you will get the current in opposite direction. So if I substitute the value of VA, so VA is VA in this equation here, I got 15/2, that is 7.5. Let us write 7.5. 7.5 minus 5/6. That comes out to be 2.5/6. I can rewrite that as 25/6 into 10, 5/12 ampere is the answer, which is in this direction. So what is the current through 5 ohm in this direction? So the current answer is minus 5/12 ampere. So we are getting this answer minus 12/5 even after the source transformation, and also we are getting through mesh analysis the same minus 5/12. Also we are getting through Thevenin theorem minus 5/12. Let us say some student will go for superposition theorem. If I go for superposition theorem, I have to redraw this same circuit twice. Why? Because there are two voltage sources. One, two. The first one, when we draw, I will remove the voltage source from the network, and I will replace this with a short circuit. The second what I drawn, I will remove the current source, and I will not replace with short circuit, it will be open, because the internal resistance of ideal voltage source is 0, internal resistance of ideal current source is infinite. So therefore this will be infinite and this will be sorted. Now to solve this problem, our question is what is the current through 5 ohm. So we can redraw this circuit with the 1 ohm resistor and then 5 ohm resistor, and these two resistors we can keep it together. This is in parallel, so we can write 2 3 is 6 by 5. So now we have to find what is the current from this 5 ohm for this 5 ampere. So we can use a current division rule. Current division rule means in this wire, what is the current flowing, and there are two resistors are here. This is a 2 ohm. So the current which is flowing over here and this here is coming from this 5 ampere. So we can use the current division rule and write down that the current through this 5 ohm, let us say I, is equals to opposite resistor, sorry, not 2, 1. Opposite resistor divided by sum of opposite plus this resistance. This is the addition of these two, that is nothing but 5 plus 6 by 5. So this much into total current is 5. So we can write down that as 1 by 1 plus 31 by 5 into 5. We can straight write down 25 by 32 amperes. Sorry, not 32, 36. So 5 plus 31, 36 amperes. So we get this answer here. The current we get by using superposition theorem, first current, we can write this as I1 if we are getting 25 by 36 ampere. Let me remove this part. Yep. Next we will try to solve the same problem, the other part of the superposition theorem, and still our need is to find the value of I1. Let us write I2. So in this network we can solve it by using simple node. So V by 6 plus V by 2 plus V minus 20 by 3 is equal to 0. V 1 by 6, 1 by 2, 1 by 5 is equal to 20 by 3. V 6, 1 plus 3 plus 2 is equal to 20 by 3. So here V is 20 by 3 volts. Our objective is to get the current in this wire. So the answer will be the opposite of the current in this wire. So that is V by 6. So the current is equals to minus of I2 is equals to 20 by 3 divided by 6. Ten by 9. So I2 is equals to minus 10 by 9 ampere. So now we have got two currents over here. One through the superposition theorem. For one source we get I1 like this. From another source we get another current. So what we are going to do, we are going to add these two currents. So adding these two currents, what we'll get? So total current I is equals to I1 plus I2, 25 by 36 plus minus 10 by 9, multiply 4 both sides, you will get minus 15 by 36, and that gives minus 5 by 12 ampere. Now you can see that through superposition theorem also we are getting the same answer as we get it from the Thevenin theorem, mesh analysis, node analysis. We are getting the same. One question is asked that if the node of this is A and B, what is VAB? Find it by using node analysis. So if we use a node analysis, and let us take it as problem again. And node analysis we'll use, we will select this node as 1 and 2. Our objective is to find the voltage here, plus minus the voltage across 3 ohm, that is VAB. Let us first solve it using node analysis. After that we will find. So what we are going to do, we want to find what is the current from here. So once we know the current into the 3 ohm is the voltage. So We'll use a node analysis for node 1, assuming that all the current is going out. We can write here it is a minus 5 and V by 1 and V1 minus V2 by 5. Zero. Equation 1. And for node 2, we can write V2 minus V1 by 5, assuming that all three currents is going out. So we need to just solve these two problems and find out the value of the V2 here. So let us quickly solve this problem. We can write that as V1 1 plus 1 by 5 minus V2 by 5 is equal to 5. So 6V1 minus V2 is equals to 25. And the second we can rewrite equation 3. And node 2 equation 2 we will solve again. V1 minus V1 by 5 plus V2 1 by 5 plus 1 by 2 plus 1 by 3 is equals to 20 by 3 minus V1 by 5 plus V2, let's say 30, 6 plus 15 plus 10 is equal to 20 by 3. We can multiply 6 both sides, minus 6V1 by 30 plus 31V2 by 30, 20 by 3, and that can be written as minus 6V1 plus 31V2 is equal to 200. So we get one equation here, equation 4. We get equation 3 here. Let us take this equation 3 and rewrite below it. So what we can observe here is we can cross this to add. By adding these to 4 and 3 we can remove this term, and what we get is 31V2 is equals to 225, sorry, not 31, 30. So V2 is equals to 15 by 2 volts. We get the value of V2 here. Now this V2, what we get here, 15 by 2 volts, you can check. 15 by 2 is nothing but 7.5 volts. Now what is the current which is flowing down is here, right? So I am going to substitute this value of V2 in this equation here, only this particular equation. So what we can rewrite that 7.5 minus 20 by 3 is equals to minus 12.5 by 3, or that is equals to, let it be like this, minus 12.5 by 3 ampere. So the current which is going downward is minus 12.5 by 3 ampere. So the question is asked, what is the voltage? What is the voltage across A and B? Where A is B is this terminal. So we can write VAB is equals to 3 times of minus 12.5 by 3. So answer is minus 12.5 volts. That's the answer of VAB. So what we can see is that single problem we have solved in multiple ways and we get a common answers in all. If you find the V1 and V2 here also and you subtract V1 minus V2 by 5, you will get the current through this 5 ohm, the same answer. Also if you take V2 by 2, you will get the current through the 2 ohm resistor and it will be same as the previous other two. And this is how we can solve the same problem in multiple ways and we get the common answer, and our concept is getting more, confidence is getting more and more after solving it in different ways. Thank you.